Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay. Hello, everyone, and welcome to our presentation. Today we're going to be talking about Airbnb, or Airbrb. Thank you for the laugh. Predicting loyalty. So we're going to see if a guest, if they rented out their room on Airbnb, will want to come back, and if you're a guest staying in Airbnb, whether or not you come back to Airbnb in the future to stay again. So what is the sharing economy? I think this tweet perfectly sums it up. 1998, don't get in strangers' car, don't meet people from internet. 2016, literally summon strangers from internet to get in their car. This is, of course, talking about Uber. So the official definition of the sharing economy is the exchange of goods and services between ordinary people by ordinary people. So what is mine is yours for a fee is essentially what it's saying. So for here, we have an example of two people sharing a car. So this is the model of Uber. And here we have two people sharing a room, which is the model for Airbnb. So a little bit more about Airbnb. This is Airbnb.com. This is what the website looks like. It's a place where you can go and you can rent out a room. You can either be the person doing the renting or you can stay in the room. And last year, I traveled a lot. I was studying in London, so I went around Europe a lot. And so one of the places I went to was France. And if I wanted to go for one night, let's say I put in tonight's date for 2 nights for 2 guests, this is what I'll see. You can see the location of all the listings of Airbnb that you could stay in. And you can see the first one here shows a listing that has 5 stars. And this one, and with lots of reviews. And this one has no reviews, no stars. Actually, 1 review. Yeah, so I probably wouldn't want to stay there, but I'd want to stay there. So Airbnb has a very clear concept of A, the guests, and B, the hosts. The guest being the person staying, and the host being the one doing the renting of your spare space. And so to give you some context of how big Airbnb is as a company, the largest hotel chain in the world is called the Intercontinental Hotel Group. They have 742,000 rooms. Airbnb has 2 million. Airbnb has been around since 2008 and is only projected to grow even more. So this is an incredibly important thing in the sharing economy, and it shows why it's important to study now. So the Intercontinental is worried about having guests that want to stay in their rooms. Airbnb has that same problem, but it has the additional problem of needing to find hosts to rent out their rooms. Because without the hosts, how will you get the guests? Imagine Airbnb as a hotel with rooms that you constantly need to convince to come back every single night. That is Airbnb, and how many rooms do we have each night? Is that number predictable? So these were some questions we had when we were looking at Airbnb. So we converged to a research question, and that is, how do we predict the loyalty of hosts and guests on Airbnb? These are some finer questions we went into. So how can loyalty be quantified? Are there certain characteristics in hosts and guests that mean that we can predict if they're loyal or not? And how does host loyalty interplay with guest loyalty? So if, let's say, a loyal host gets a loyal guest, does that mean they're both more likely to be loyal in the future? Or if you don't get a loyal host, would that spoil your experience with Airbnb? So we're looking at that interplay as something very important and very new and distinct to the sharing economy. So a little definition of what the loyal host is. The loyal host is someone who continues to list their space out on Airbnb. And the loyal guest is someone who continues to book a space out on Airbnb. And Airbnb has found this quite important, and they have something actually called the Superhost program. And that's something like a platinum frequent flyer card, you can imagine that to be, for Airbnb. You have to jump through a lot of hoops. You have to have your listing on for a year and a lot others. But you get a special recognition for people, for your loyalty to Airbnb. And with that, I'll give it over to Cassidy, who'll talk about the data a little more.
So our data was courtesy of Inside Airbnb.com. This data is scraped from the official Airbnb website monthly. This is basically a snapshot in time of the web page at that moment. The data ranges from January 2015 up to July 2016. And all the data is organized by city, and it consists of 3 data sets, which is the listings, calendar, and reviews data set. The listing data set involves information on listings, properties, all of that. And calendar data set pertains to availability throughout the year. And reviews data set refers to reviews and review text throughout the year. We would like to extend a special thanks to Murray Cox, the founder of InsideAirbnb.com, for making this data publicly available for all of us. So let's take a look at host data. Host info is taken from the listings data set, and it consists of ID, name, start date, amongst other host details. And it also has info on the property the host is listing, like ID, price, location, reviews, amenities, etc. Now, the guest data is taken from the reviews data set, and this involves the listing ID, where the guest stayed, the comment ID, the user ID, as well as the reviewer's name and the review text that's associated with their stay. So as we looked at the data, we did some exploratory plots. This is a map of number of listings by neighborhood. As you could see, there's a high concentration of listings in the lower Manhattan region, as well as parts of Brooklyn, specifically Williamsburg. Now we have a plot on the most frequent words in review text. On the x-axis, we have words. On the y-axis, we have the frequency of the words. And the most frequently used word in review text is great, followed by stay, as well as place. Now we have the average review rating by number of stays. And just before we go on, I would like to say that reviews were used as a proxy for stays, because we assume that if you leave a review is because you booked that place and you stayed there. So on the x-axis, we have review score rating, and on the y-axis, we have number of reviews. And it shows that the more reviews you have, the higher your rating is, and vice versa. So now setting up the prediction problem. Once again, to remind you, our goal was to find out how host loyalty could be predicted and how guest loyalty could be predicted. We compiled all of guests and reviewers from 2015, and we kept one listing per host because some hosts have more than one listing. We kept it to one listing so it doesn't skew our results. We calculated attributes for 2015 as well as 2016. Our 2015 attributes were predictor features, and our 2016 attributes were target features. At the end of all this, we dealt with missing values. We accounted for them. We accounted for them. We know the reason why they are missing, and we dealt with them. Now these are some of our host predictor features. We've broken them down into subsets, which include price, reviews, date, and place. And here are a few more, known as amenities, location verification, and interplay. Interplay is a very important subset. It plays into the interaction between guests and hosts. And we have the recency frequency subset, which turns out to be one of our most important predictors. And here are our target variables. It includes has reviews 2016 as well as exists in 2016. These are our target variables because we would like to know if these hosts come back in 2016 based on what has happened in 2015. So here are our guest predictor features, which include words, recency frequency, once more, and interplay. And then our target is has reviews in 2016. Once again, whether the guest comes back in 2016 based on what has happened in 2015. So after getting all our features together, we did some plots to show some relationships between predictors and target variables. So over here, we have 2015 versus 2015 and 2015 versus 2016. So there's a relationship between the number of reviews and the amount of times a listing shows up in a year. So the more reviews you have in 2015, the more times you show up in 2015, the more reviews you have in 2015. And the same goes that the more reviews you have in 2015, you actually do show up in 2016 a lot more. So then this is our setup. So we went on to do modeling, and we subsetted our data sets into training and testing sets. We used the 80% of our data set for training, and then the rest was for testing. When we trained our models on the training set, and we did cross-validation before testing on the testing set. So now our models, we decided to use decision trees for modeling because it finds patterns in the given data to predict on unseen data. And why did we use decision trees? Because they handle missing values very well. They're very intuitive and easy to comprehend, and they do feature selection for you, which is very efficient. This is an example of a decision tree, and Jackie will go into more detail on them.
So now I'll begin to discuss our results that we found. So first I'm going to focus on host loyalty. The first step we needed to do was to choose a proxy for the actual number of stays there were in 2016. So just to remind you, we're using the New York data for the listings. And to gauge host loyalty, we looked at two metrics, which Cassidy has mentioned. We have listed in 2016 and reviewed in 2016. So to be listed in 2016, we said if they had one occurrence in 2016, they were considered to be listed. If they were reviewed in 2016, they had one review in 2016. However, in practice, we could change this number of reviews or occurrences as the outcome, and our methods would be exactly the same. So both of these are useful proxies, but they both also have their limitations. So to start with listed in 2016, just because something is listed doesn't mean someone's actually staying there or it's being actively rented out. In addition, for reviewed in 2016, one guest leaves a review, but that doesn't mean every guest is going to leave a review. Also, reviews can be entered up to 2 weeks after a stay. So for those staying at the end of December of 2015, there may be some spillover into 2016. Despite this, we think reviewed in 2016 is the best proxy for stays, so we're going to focus on that in the interest of time. Once we defined our target, we had to describe what cohorts we wanted to look at. Since this is a prediction problem, we wanted to look at similar listings. So some of these were defined by time, some were defined how long they were listed, and so on. Again, in the interest of time, we're going to focus on January 2015 cohort, but when we did look at the other cohorts, all of these produced similar results. So first we started with the idea of recency and frequency. Marketing people stand by the idea that this is truly the best predictor of loyalty across industries. So we looked at recency frequency information for the January cohort, and here's the tree that we develop. So let's pretend that we have a listing that was in New York City and has not gotten a review since February of 2015. So that means 48 weeks since end of 2015 was when they received a review. So we go over to the tree and we can see 0.3 is the prior of the likelihood of a listing having a review. Then we look the last review less than 14 weeks from the end of 2015. To the right is yes, and to the left is no. So since it was 48 weeks ago, we're going to go to the left, it's no. We'll go down to the second branch here and say the last review less than 19 weeks from the end of 2015. Again, since it was 48 weeks, we're going to follow all the way down here to the leftmost leaf. This top number is the empirical probability that a listing that reaches this leaf will be reviewed in 2016. The number underneath this is the percentage of listings that will end up in this leaf. We get an AUC value for this model of 0.9. And AUC is a ranking statistics to see how well our model is doing in comparison to the actual result. So this ranges from 0.5, which is random, and 1, which is perfect. So for 0.9, our baseline model performed fairly well. But we wanted to see if we could beat this, and using these other subsets, see what sort of information we could garner. So we discovered something new, that recency frequency was great, but individually, certain of these subsets could also perform very well. So for example, we looked at 100 of the top most used words in reviews, and we found the strongest predictor here was Subway. So if a listing had the word Subway, that listing was more likely to be loyal and be reviewed in 2016. And the AUC for this was 0.79. We also looked at these interplay features that we have been discussing. So taking for each listing whether or not the guests that stayed there were loyal. So the last reviewer's first review date had a positive impact if it had been more recently, and that led to an AUC of 0.86. Lastly, we also looked at amenities. So for each listing, we have information about the amenities that they offer to people. So for example, hairdryer we found to be the most predictive, and we got an AUC for this of 0.69. So although none of these were able to beat the recency frequency, we were able to realize interesting connections. So we're not saying there's causation, but there's certainly an interesting correlation between certain characteristics. So when we look at the recency frequency and amenities tree, you can see a lot of the similar characteristics we saw in the first tree, but we also see, do they have a hairdryer? So this is an interesting connection we see. We hypothesize that perhaps someone who's offering more amenities to their guests is more likely to be committed to Airbnb and thus be more loyal and more likely to return. So we see a slight improvement in AUC to 0.91. From all the trees we looked at, we found a few things. First, those people who are listed more often, and we see them more often, so therefore recency frequency, are more loyal. However, the other features such as review words, amenities, alone are predictive in themselves. In addition, combining all of these features has given us a slight improvement as well as just allowed us to realize interesting connections. But really, this is only one piece of loyalty that we looked at. So now Erica will go on to discuss the guest loyalty.
Now we're going to be switching over to looking at guest loyalty. When looking at guest loyalty, we are trying to predict guests returning to Airbnb. To do this, we're looking at the reviewer dataset, and also that the reviewer dataset has a different structure to it, and it has less features. So there is less data available than the hosts, and also that while every host has a listing, not every guest leaves a review for every stay. We determined that the New York data was too sparse, and there was only very few reviews, so we determined that using a US data set that covers stays for the entire US was a better measure. The target variable we're looking to predict on is whether or not the guest leaves a review in 2016 or not. There are two limitations for this, though. Guests are not required to leave a review for every stay, so there also may be stays that aren't accounted for in our numbers. And also that because we only have US review data, we can only look at stays in the US, so if they stayed elsewhere, that will not be counted. For the guest data, we also looked at cohorts, and we looked at the January 2015 cohort. We looked at people who had more than 1 and more than 5 reviews, and also people who had exactly 1 reviews, who are first-time users in 2015. What predicts a guest return? Recency and frequency were also the best predictors for looking at guest returns. However, compared to looking at hosts, we ended up achieving a lower AUC. And the features that were picked out here were the distance from the end of 2015 until from the end of 2015 until the review, and also the number of reviews in 2015. Because the AUC is lower, we're able to determine that it's harder to solve the problem. And why is this problem different than looking at the hosts? It's different for 2 reasons. Because compared to the host data, there's very few features for reviews. But we also created interplay values with the guest's last stay. And also there's not enough reviews per person. So we also created a cohort of people with more than 5 reviews. The best model that we achieved for the January 2015 cohort was actually recency frequency features and interplay features, and you can see that it increases the AUC by a slight amount from 0.65 to 0.66, and you can see that in the inclusion of the rating score of the listing and also in the minimum number of nights. People who stay with people who have higher ratings are more likely to come back to Airbnb. We also looked at other trees for the January 2015 cohort, including features such as review words, the interplay features from their last stay, and with all the features. And we achieved AUCs of 0.59, 0.59, and 0.65. In this plot, the x-axis shows the number of reviews in 2015, and the y-axis shows the number of guests who left that many reviews. As you can see here, the number of reviewers is skewed by the majority leaving exactly one review. This is the second reason that it was difficult, as very few people have more than one review. There are a lot of guests for whom we don't have a lot of information, and that's why we chose to restrict to guests who had more than 5 reviews. And in a model looking at the overall, looking at reviews in 2015 more than 5, for recency frequency, we were able to achieve an AUC of 0.76. And these are people who we have more data for because they've left more reviews and have stayed more. The findings we found in predicting guest loyalty is that predicting guest loyalty brings new challenges that we discussed, as the lack of data and the lack of information per guest. Recency frequency also continued to be the best for predicting, especially for guests that we had more information about. And the interplay features do show that they add value to the models. Even though we were able to build predictive models for both host and guest loyalty, there were some limitations in the data sets. The data that we have is scrape data. Therefore, it's a snapshot of the website at the time that it was taken. Certain features, such as amenities, weren't included in some of the earlier snapshots, so that accounted for some of the missing data. And we only have data sets that date back to January 2015, whereas Airbnb has been around since 2008. Using reviews as a proxy for stays has also been a limitation, as it is estimated that less than half of guests leave reviews. And also there's the probability of noisy data. For example, friends of the host stay and they leave a good review as opposed to an actual guest. And also if hosts receive a bad review on their listing, they also can delete their listing and create a new one where the bad review doesn't show. I'm going to pass it back to Lou.
Okay, thank you. So now we're about to round up. So the implications for Airbnb and the sharing economy in general. Number one, probably the most important, is that we've identified that if the guest stays with a good host for the first time, they're way more likely to come back and stay again. So their loyalty increases. So Airbnb could match hosts and guests that are loyal, so to increase both their experiences. The second thing is that if you work out some math, you can see that even though if we have a 1% increase on the people that come back to Airbnb, just in the US alone, that's a $4.68 million revenue increase, and that goes to both the host and the Airbnb as a platform. But that's quite a lot for a 1% increase, and that can be also not just used for Airbnb, but for the sharing economy models that rely on sharing in general, to find out that loyalty is very important in predicting success of their return rates. And the final slide is that if we had more time, we'd love to tackle more of these issues, expanding to the world instead of just the US and New York City with our analysis, using different time periods to predict the future, using additional models, and potentially using data mining for social good, and addressing some of these questions that we have below. So that's it for our presentation. Now we're moving into questions, and we're more than happy to take any if you have. So thank you. questions. Hello, yes.
How would you use Airbnb to fight homelessness?
That's a really interesting question. Let's put that back up. So one of the things we thought about is that if you know that you're going to have a spare room for that night, you could incentivize guests or subsidize hosts to allow low-income guests to stay at a discount very temporarily. So that could be something that helps the buffer between finding somewhere new to stay versus just straight up being homeless. Sure.
Did you find any data that was confusing in the beginning and then it made sense?
I definitely know confusing in the beginning, yes. Definitely we found a lot that was confusing in the beginning, but that started to make sense towards the end a lot too, I guess, but I'm trying to think of a specific example. Do you want to talk about that? Yeah.
Amenities are your realm.
Okay, all right. Yeah, it was interesting to see how, as we showed, we had some hairdryer amenities coming up, and so we were really confused about that. And we plotted a lot of different graphs with a lot of different cohorts, and one of the things that came up was also iron. So it seemed that it didn't matter how long you had stayed on Airbnb. If you had an iron, you would be, for some reason, you'd come back more. And so we had to guess. We weren't really sure, but I think I estimate that if you have more amenities in general and you have, it seems like you put more effort into your listing, you're more likely to come back as a result. So that was one of the more interesting ones, yeah. Yeah, thank you. A couple of super weird listings. Yes, so you have a maximum limit of how much max price of the place you rent out. Someone put a $10,000 apartment that was really, really bad. I think it was a troll listing. There was also a place that was renting out a hotel. There's 38 listings of the same building because they were running a hotel scheme, and that's technically illegal. Yeah. Ooh, more hands. Ooh, so many hands. Okay. So I think Sid. Okay. Yes.
I was just wondering, you mentioned that you selected one listing for hosts that had multiple listings.
That's right.
And I was wondering, was there any sort of scheme that you used to select that one listing, or was it random?
It's exactly random. So you can have, so let's say if I have 3 apartments, the way we did our analysis was that I didn't have all 3 of my apartments in the data set. We just randomly selected one of my apartments to be in the data set. The reason being is that because if you have 38 listings, the hotel guy, you're going to massively skew our data. And so we randomly picked which ones that we included in our data set. So I hope that answers your question. It was a random selection. Yeah. Yes?
Do you think like other services like couch surfing or like hotels amalgamating that data together might like having all of that big data together, does that sort of hurt the integrity of some of these other questions you might be wondering in the future, or do you think sticking to like one service like Airbnb would be better?
I think if we have all of them together, questions about the sharing economy would be easier to understand. For example, how many people want to rent a stranger's home? That will be a question that's a lot more easy to understand if we had all this data. But keep in mind, Airbnb has like nearly 99% of the market share of a sharing economy flats that you rent out. So I think even if we included it, the difference would be minor. And the information on Airbnb is much more comprehensive than the ones offered elsewhere. So in that answer, it probably wouldn't affect too much, but if it would, for the sharing economy, things would probably be clearer, not any worse. I feel like I'm speaking a lot. You guys did a lot too.
Can you talk about hosts coming back? Can
We
you
did,
explain
yes.
that a little more and talk about maybe the gaps or the intervals that you noticed in terms of hosts returning to the system? That's kind of
Okay, so, well, in terms of hosts coming back or even listings coming back, Sometimes hosts may want to list their listing at the beginning of the year, but something happens in the middle of the year where they decide to go away and then they come back. That's why we had the feature of total occurrences within 1 year, because there have been trends of listings being taken off and put back on. There was also an issue of purging. I forgot which month that happened. It was in November. Yeah, so there was an issue of purging in New York City because there was a lot of multi-listers, a lot of entire home multi-listers, and there was the concern of legality of listing entire apartments.
Why did you define what purging means?
So purging is Airbnb removing your listings. You have more than one listing, you probably have at least 3 listings or more, and they go in and delete at least 1 or 2 of your listings, depending on how many listings you have. So that's considered purging. So there was a lot of listings before November 17th that disappeared after. So that's one example of listings coming back in, like leaving. And I'm not too sure if they would come back in. If they do come back in, they probably have a different ID number. So does that answer your question? Okay.
Any other questions?
How many rows of data you had?
How many rows? Okay. Well, which data set? There in reviews data set had like almost 3 million, but that's after we like sized it down.
And sized it down one more time, and
yeah.
it had about 2,269,000.
Yeah.
So
So
it was pretty large.
yeah, so most of them were in the billions because we took every listing data, like for listings, we took every single listing data set from January 2015 all the way up to July 2016 and like smashed them together. And we had to take out multi-listings and do distinct like hosts and all that. So when we did data cleaning, we were able to get the listings data to about 64,000 like unique listings or unique hosts. But prior to that, it was like in the millions for both hosts and guests.
So would you describe that as big data?
Well, to me, it's big data, so because this is the first time I was dealing with that much. So
I would call it not big data because it fits on one machine. Maybe not simultaneously, but it's pretty big. I mean, barely fits in memory.
Question?
How much seasonality did you observe in terms of, available listings? Because, for places like Lake Tahoe, you would expect lots more listings in, say, the winter time or the summertime.
So firstly, we looked at New York City data for hosts, so we weren't sure about places like Tahoe, but yeah, definitely that intuition of there being more around like Christmas. There was definitely a little bit of an increase, but not that much, actually. It was more seasonality in terms of how long Airbnb has gone up. It seems like there's a general upwards trend, but the increase per month at max was like 400 or like 200 like per month. Yeah, there wasn't much seasonality. The thing is that we had scraped data. We weren't able to see the official bookings. So there may be a lot of listings that are like on the website, but we don't know how many of those listings were actually booked. I'm sure if you had that information, that's information that Airbnb keeps to its, themselves. If we had that information, we'd be able to answer the question of seasonality much better. We wish we had that data, but we didn't. Yeah, to answer that, not actually that much, surprisingly. A little bump towards the end, towards Christmas, but by only 400 listings out of 36,000, so that's not too much.
What software tools did you use to analyze the data?
So R was our backbone. R was where we did most things. We did some Python. Did we do anything else?
We plotted things using ggplot.
All Microsoft products.
Microsoft PowerPoint.